In this lecture, we will find the area of triangle ABC in two different ways. We will start with the first method. In the drawing, we have triangle ABC. We know that side AB of triangle ABC equals to 8 units. Side AC of this triangle equals to 14 units. And we also know that angle ACB, this angle equals to x degrees, and angle ABC, this angle equals to 2x degrees in size. And we want to find out the area of this triangle ABC. So first of all, we will draw a line segment from point A until it touches BC side at point D in such a way that line segment AD will create angle of 2x with BC. Okay, so we will draw the line segment AD in such way. First of all, the touching point between the line segment and BC is at point D, and we drew line segment AD in such way that angle ADB equals to 2x. Okay, again, we drew line segment AD in such a way that angle ADB equals to 2x. So actually, in triangle ABD, this triangle, we have two equal angles. Both of those two angles are equal to 2x. And we have a rule again. In triangle ABD, we have two angles that are equal to each other. Angle ABD equals to angle ADB. Both of those two angles are equal to 2x. Okay, and we have a rule. I will call it rule number 1. According to rule number 1, if two angles inside a triangle are equal to each other, then the sides that are in front of those angles are also equal to each other. So I will read rule number one again. Rule number one states that if two angles inside the triangle are equal to each other, then the sides that are in front of those angles are also equal to each other. So actually, if we have triangle ABC, that can be any other triangle, not necessarily our triangle, but any triangle. We have triangle ABC, and we know that two angles inside triangle ABC are equal to each other. For example, this angle is angle alpha, and this angle is also angle alpha, so those two angles are equal to each other inside triangle ABC. Okay, those two angles are equal to each other inside triangle ABC. Then, according to rule number one, the sides that are in front of those angles, that is to say, we have side AC in front of this angle, will be equal to side, and in front of this angle we have side AB. Side AB is in front of this angle, angle alpha, will be equal to AC. So actually rule number one states that in front of equal angles we have equal sides. Okay, I can even say that rule number one states that in front of equal angles in a triangle, of course, we have equal sides. Okay, so AB is in front of this angle alpha, and AC is in front of this angle alpha. Therefore, in front of equal angles we have equal sides, that is to say AB equals to AC. Okay, AB equals to AC, according to the rule that in front of equal angles, those two angles are equal to each other, and in front of this angle alpha we have side AB, and in front of this angle alpha we have side AC. So in front of equal angles we have equal sides, so the sides that are in front of the equal angles are also equal to each other. That is to say, AB equals to AC. Okay, so actually we can implement rule number 1 in our drawing, because we have triangle ABD. In triangle ABD, this triangle we have two equal angles. According to rule number 1, in front of equal angles we have equal sides. That is to say, AB, that is in front of this angle 2x, will be equal to AD, that is actually in front of this angle 2x. Okay, so again, in triangle ABD we have two equal angles. Therefore, from rule number 1 we can deduce that AB also equals to AD. AB equals to AD, according to rule number 1, that states that in front of equal angles we have equal sides. Okay, so according to rule number 1, in triangle ABD we have two equal angles. Angle ADB equals to angle ABD. Both those two angles equal to 2x. Okay. In triangle ABD we have two angles that are equal to each other. Both those two angles are equal to 2x. Therefore, according to rule number 1, AB will be also equal to AD. AB will be also equal to AD because in front of equal angles we have equal sides. But we know that AB equals to 8 units. It is given us in the question. So we can write here that AB equals to 8 units. Okay, AB equals to 8 units. It is given us in the question. So from this equality we can deduce that AD also equal to 8 units. Okay, AD equals to 8 units. So AD equals to 8 units, and we have rule number 2 that states, rule number 2, before I explain to you, before I present rule number 2, I will explain you what is exterior angle and what are interior angles. Actually, if we have triangle ABC, we will extend side BC so this will be L. So we have this angle ABL. This angle is exterior angle so angle ABL is exterior angle in relation to triangle ABC, because triangle ABC has 3 interior angles: alpha, beta, and gamma are defined as interior angles. Okay, so those 3 angles are interior angles. And this angle is also interior angle. Okay, so actually triangle ABC has 3 interior angles. Angles alpha, beta, and gamma are defined as interior angles because of the fact that they are inside triangle ABC, while angle ABL is defined as exterior angle of triangle ABC because of the fact that angle ABL is located outside triangle ABC. For that reason, angle ABL is defined as exterior angle of triangle ABC. Okay, so we have 3 interior angles: angle alpha, beta, and gamma are interior angles, and angle ABL, this angle is defined as exterior angle. Angle ABL, this angle is defined as exterior angle of triangle ABC. Actually, those 2 angles, angles alpha and beta, are opposite interior angles in relation to angle gamma. Those 2 angles, angles alpha and beta, are defined as opposite interior angles. Okay, so again, angles alpha and beta are defined as opposite interior angles in relation to angle gamma because of the fact that they are located in opposite sides in relation to angle gamma. That is also interior angle of triangle ABC. So again, those two angles alpha and beta are defined as opposite interior angles in relation to angle gamma, and angle ABL, this angle is defined as exterior angle of triangle ABC. Okay, angle ABL is exterior angle of triangle ABC. Again, angle ABL is exterior angle of triangle ABC, while angles alpha, beta, and gamma are interior angles of triangle ABC, and angle alpha and beta are defined as opposite interior angles in relation to angle gamma because of the fact that they are located in opposite sides of angle gamma. This angle alpha is the opposite side of angle gamma, and this angle beta is in the opposite side of angle gamma. So those angles, angle alpha and beta, are defined as opposite interior angles. Okay, so now I will present rule number 2 that talks about exterior angle and interior angles. So actually, rule number 2 states that exterior angle of a triangle equals to the sum of the opposite interior angles. I will read rule number 2 again. Rule number 2 states that exterior angle of a triangle equals to the sum of the opposite interior angles. So rule number 2 states that the exterior angle ABL equals to the sum of the two opposite interior angles. That is to say, angle ABL, the exterior angle ABL, equals to the sum of the two opposite interior angles. Those angles are opposite interior angles, so the exterior angle ABL equals to the sum of the two opposite interior angles. That is to say, the exterior angle ABL equals to the sum of the two opposite interior angles, that is alpha plus beta. So according to rule number 2, the exterior angle ABL equals to alpha plus beta. Okay, again the exterior angle ABL equals to alpha plus beta, that are actually the opposite interior angle in relation to angle gamma. So angle ABL equals to alpha plus beta. Again, the exterior angle ABL equals to alpha plus beta. So here we can write that angle ABL equals to alpha plus beta. Okay, so this angle ABL, the exterior angle ABL equals to alpha plus beta. That is alpha, and that is angle beta. The exterior angle ABL equals to alpha plus beta. Okay, so we actually can implement rule number 2 in our drawing, because if we relate to triangle ADC, in triangle ADC we have actually angle DAC, and angle ACD are defined as interior angles of triangle ADC and according to rule number 2, angle DAC plus angle ACD, the sum of the two interior angles, angle DAC plus angle ACD equals to the value of the exterior angle ADB, that is actually 2x. Again, according to rule number 2, angle DAC plus angle ACD equals to the value of the exterior angle ADB, that is actually 2x. Again, according to rule number 2, the two interior angles of triangle ADC, the sum of the two interior angles of triangle ADC, that is DAC plus ACD, this angle plus this angle, will be equal to the exterior angle, that is angle ADB, that equals to 2x. So angle DAC plus angle ACD equals to 2x according to rule number 2. Okay, but what is the value? So the value of angle DAC is unknown, so I'll write it as it is. DAC, angle DAC, we don't know the value of angle DAC, but angle ACD is given us. We know that the value of angle ACD is x degrees in size. So we can substitute ACD angle ACD by x, because angle ACD equals to x. So angle DAC plus x will be equal to 2x. Okay, we have this equality that states that angle DAC plus x equals to 2x. Here we can subtract x from this equality, and we will get that the value of angle DAC equals to 2x minus x, that is x degrees. So angle DAC equals to x degrees in size. So here we can write down that angle DAC equals to x degrees in size. So we actually, in triangle ADC, we have two equal angles. Okay, in triangle ADC, we have two equal angles. Angle DAC, this angle, equals to angle ACD, and both those two angles are equal to x. Okay, again, in triangle DAC, we have two equal angles. Angle DAC equals to angle ACD. Both of those two angles are equal to x. They are x degrees in size. So we have rule number 1 that states that in front of equal angles in a triangle we have equal sides. So in front of this angle x we have side AD, and in front of this angle x we have side DC. And according to rule number 1, AD equals to DC. Again, according to rule number 1, in triangle ADC that we have two equal angles, AD also equals to DC according to rule number 1. AD equals to DC because in front of equal angles we have equal sides, that is to say AD equals to DC. Okay? According to rule number 1, in triangle ADC we have two equal angles, therefore AD equals to DC according to rule number 1. Okay, but we know, we have already found out that AD equals to 8 degrees. So we can write here that AD equals to 8 units. AD equals to 8 units. AD equals to 8 units in size. So AD equals to 8 units. From this equality we can deduce that DC also equals to 8 units. Okay, DC equals to 8 units. Okay, DC equals to 8 units. So you can write in the drawing that DC equals to 8 units. Okay, so actually we have in this drawing two isosceles triangles. Triangle ADC is an isosceles triangle because in triangle ADC side AD equals to side CD, and we have also the second isosceles triangle. Triangle ABD is isosceles triangle because it has two equal sides, that is to say AB equals to AC equals to 8 units. Okay, and in relation to isosceles triangles we have a rule. I will call it rule number 3. Rule number 3 states the height to the base in an isosceles triangles divide the base to two equal sides. Rule number 1 states that the height to the base in an isosceles triangle divide the base to two equal sides. To two equal parts, okay? I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divide the base to two equal parts. So if we have an isosceles triangle, if triangle ABC is an isosceles triangle, that is to say it has two sides that are equal to each other. So in triangle ABC, that is isosceles triangle, we have two equal sides. So triangle ABC is an isosceles triangle, that is to say it has two equal sides. That means that side AB equals to AC. AB equals to AC, so triangle ABC is an isosceles triangle AB equals to AC. So if we, and the base of triangle ABC is BC. The base of triangle, of the isosceles triangle ABC, is side BC of the triangle, is BC. So if we draw a height to the base, what is the height to the base? The height to the base is actually perpendicular to the base. Okay? If you draw a height to the base, it means that you actually draw from point A perpendicular to the base BC. Okay, if we draw a perpendicular to side BC of triangle ABC, so this angle is a right angle, and this angle is also a right angle. We define the touching point between the perpendicular that we drew to side BC as point D. Again, D is the touching point between the perpendicular to side BC. So AD is the height to BC. Okay, that is the perpendicular to the base BC. That is the height to the base BC. AD is defined as the height to the base BC because of the fact that it creates 90 degrees with the base BC. AD is defined as the height to the base BC. So according to rule number 3, the height AD to BC, to the base of triangle, of the isosceles triangle ABC, the height AD divides the base BC to 2 equal parts. That is to say, BD equals to DC. According to rule number 3, the height AD divides the base BC to 2 equal parts. That is to say, BD equals to DC. BD equals to DC according to rule number 3. BD equals to DC according to rule number 3. Okay, so that is the meaning of rule number 3, that if you draw a height to the base of an isosceles triangle like triangle ABC, then the height divides the base to 2 equal parts. That is to say, BD equals to DC. Whenever you draw in an isosceles triangle an height to the base, that height, in this case is AD, that height divides the base BC to 2 equal parts. That is to say, BD equals to DC. Okay? And again, we can implement rule number 3 in our drawing, because we have two isosceles triangles in the drawing. We relate to the isosceles triangle ADB. triangle ADB is an isosceles triangle because AB equals to AD. Both those two sides are equal to 8 units in size. So in the isosceles triangle ABD, in the isosceles triangle triangle ABD, if we draw perpendicular in this case, in the isosceles triangle ABD, the base is BD, the base of the isosceles triangle ABD is BD. So if from point A we draw a perpendicular to the base BD, okay, we will draw a perpendicular to the base BD, okay, then so this is perpendicular to the base BD, that is to say this angle is a right angle, and this angle is also a right angle, it equals to 90 degrees. And we will call to the touching point between the height to the base BD point E. Point E is the touching point between the perpendicular to the base BD. Okay, and we will define AE as H. That is to say AE equals to H, because actually AE is the height to the base BD. Okay, AE, that is H, is the height to the base BD because of the fact that it creates 90 degrees with the base BD. That is to say this angle is 90 degrees and this angle is also 90 degrees. Okay, so according to rule number 3, the height AE divides the base BD to two equal parts. That is to say, BE equals to ED. Okay, according to rule number 3, BE equals to BD. Okay, BE equals to ED. Again, according to rule number 3, in the isosceles triangle ABD, BE equals to ED because the height AE divides the base BD to two equal parts. And if we define BE as A, that is to say BE equals to A. So if BE equals to A, then DE also will be equal to A. From this equality we can deduce that BE also equals that ED also equals to A. Okay, ED also equals to A. So ED also equals to A. And actually we have here in the drawing we have two right triangles. Triangle ABD is a right triangle because of the fact that angle AEB is a right angle, and triangle AEC is also a right triangle because of the fact that angle AEC is a right angle. Okay, so if we relate to the right triangle, triangle ABE, in the right triangle, triangle ABE, in the right triangle triangle ABE, in this right triangle, triangle ABE, okay, so in the right triangle, triangle ABE, we can implement the Pythagoras theorem. According to the Pythagoras theorem, in the right triangle, triangle ABE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in triangle ABE is AB. This angle is 90 degrees, so the hypotenuse is in front of the biggest angle, it is 90 degrees, so AB is the hypotenuse in triangle ABE. The square of the hypotenuse, that is to say AB square, this will be equation number 1, AB square will be equal to the sum of the squares of the perpendiculars, will be equal to AE square plus BE square. Okay, so in equation number 1, we implemented the Pythagoras theorem in the right triangle, triangle ABE. The square of the hypotenuse is AB square equals to the sum of the squares of the perpendiculars equals to AE square plus BE square. But what is the value of AB? AB equals to 8 units in size, it is given us in the question. So AB square is 8 square. 8 square is 64. What is the value of AE? AE equals to H. According to our definition, it is actually the height to the base BD. So AE square is H square plus BE square. What is the value of BE? BE equals to A according to our definition, so BE square is A square. Okay, so in total we got in equation number 1 that 64 equals to H square plus A square. Here we will subtract A square from this equation, equation number 1, and we will get that H square equals to 64 minus A square. So we subtracted A square from this equation, equation number 1. We got that H square plus A square minus A square is H square. and 64 minus a square minus a square equals to 64 minus a square. So h square, according to equation number 1, h square equals to 64 minus a square. Okay? So, in the next step, we will relate to the right triangle, triangle AEC. Again, triangle AEC is a right triangle because of the fact that angle AEC equals to 90 degrees. Okay, I write it down. Triangle AEC is a right triangle because angle AEC is a right angle. This angle is a right angle. Again, triangle AEC is a right triangle because angle AEC is a right angle. We actually draw AE to the base BD, therefore this angle is 90 degrees and this angle is also 90 degrees. So this angle is 90 degrees, therefore triangle AEC that contains one angle that is 90 degrees is a right triangle. And again, we can implement the Pythagorean theorem in the right triangle, triangle AEC. Okay, so according to the Pythagorean theorem, in the right triangle, triangle AEC, the square of the hypotenuse in triangle AEC is AC, and the square of the hypotenuse is AC square. This is equation number 2. AC square will be equal to the sum of the squares of the perpendiculars, will be equal to AE square plus EC square. Again, in equation number 2, we implemented the Pythagoras theorem in triangle AEC. Triangle AEC is a right triangle, so we can implement the Pythagorean theorem on the right triangle AEC. According to the Pythagorean theorem, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. Okay, but what is the value of AC? AC equals to 14 units. It is given us in the question. So AC square is 14 square. 14 square is 196. What is the value of AE? AE is the height to BD. So AE equals to H according to our definition. Okay, so AE square is H square. And what is the value of EC? EC equals to A plus 8. Again, EC equals to A plus 8. So EC square will be equal to A plus 8 square. Okay, so in total we got that 196 equals to 8 square plus a plus 8 squared. But we have already found out in equation number 1 that h squared equals to 64 minus a squared. So we can substitute h squared by 64 minus a squared, because h squared equals to 64 minus a squared. So we will do it now. 196 equals to h squared, and we'll substitute h squared by 64 minus a squared plus 8 squared equals to a squared plus 64 plus 16a. So in total we got that 196 equals to 64 minus a squared plus a squared plus 64 plus 16a. So minus a squared plus a squared is 0, so a squared is cancelled. And 64 plus 64 is 128. Okay, so I will write it down. In total, we got in equation number 2 that 196 equals to 64 plus 64 is 128 plus 16a. So in total we got that equation number 2 states that 196 equals to 128 minus 16 plus 16a. Here we'll subtract 128 from this equation number 2, and we will get that 16a equals to 68. 16a equals to 16a equals to 68. Here we will divide equation number 2 by 16 in order to get the value of a. A equals to 68 over 16. Okay, and if we divide the numerator and the denominator of this equality by 4, we will get that a equals to 17 over 4. 68 over 4 is 17, and 16 over 4 is 4. So a equals to 17 over 4 units. Okay, a equals to 17 over 4 units, but we have equation number 1 that states that h squared equals to 64 minus a squared. Okay, according to equation number 1, h squared equals to 64 minus a squared. If a equals to 17 over 4, then a squared will be equal to 289 over 16. So we got that h squared equals to 64 minus 289 over 16. So here we will take a common factor of 16 out of this equality, and we will get that h squared equals to 64 times 16 is 1024 minus 289 over 16. Okay, so h squared actually here we multiplied 64 by 16 and then we divide it by 16, so we change nothing. Okay, and we got that h squared equals to 1024 over 289 over 16. 1024 minus 289 equals to 735. So h squared equals to h squared equals to 735 over 16. Okay, here we will take a root out of this equality and we will get that h equals to the root of 735 over 16. But what is the value of 735? The value of 735 is 3 times 5 times 7 times 7. If you don't believe me, you can check that 335 equals to 3 times 5 times 7 times 7 over 16 equals to 4 times 4. So actually here the root of 7 times 7 is 7 and the root of 4 times 4 is 4. So we can take out of the root 7 over 4. Okay? It is h equals, so h equals to 7 over 4. 3 times 5 is 15, so in the root we have 15 only. Only 15 is left inside the root. Okay, so we got that the height of triangle ABC equals to 7 over 4 times root 15, and we have already found out it is units, and we have already found out that A equals to 17 over 4 units. Okay, so the height of triangle ABC equals to 7 over 4 times root 15 units, and A equals to 17 over 4 units. BE is equals to A and ED equals to A. that is equal to 17 over 4 units. Okay, so what is the area of triangle ABC? The area of any triangle equals to the base of the triangle times the height to the base. You should remember that the height must create 90 degrees with the base, otherwise it is not the height. So the area of any triangle A is the abbreviation for area, so the area of any triangle equals to the base of the triangle times the height to the base over 2, and the height must create 90 degrees with the base. So the area of triangle ABC equals to the base. The base of triangle ABC is BC. The base of triangle ABC is BC. Or side BC of triangle ABC times the height to the base. Again, the height AE, that is H, creates 90 degrees with the base BC. Therefore, H AE that equals to H is indeed the height of triangle ABC, because it creates 90 degrees with the base BC. So the height of triangle ABC is AE that equals to H. You should remember that we have already found out the value of H. So the only thing that is left is to substitute H by its value, 7 over 4 times root 15, and we already know that A equals to 17 over 4 units. Okay, so the area of triangle ABC equals to the base BC times the height to the base. The height is H, because H creates 90 degrees with the base BC. This angle is 90 degrees. Therefore, the area of triangle ABC is the base BC times H over 2. But what is the value of BC? Area of triangle ABC equals to BC. What is the value of BC? BC equals to A plus 8. Again, BC equals to A plus 8, or BC equals to 2A plus 8. And what is the value of H? As I already showed you, H equals to 7 over 4 times root 15 units. So the area of triangle ABC equals to 2A plus 8 times 7 over 4 times root 15 over 2 square units. And we have already found out that the value of A is 17 over 4 units. A equals to 17 over 4 units. So we can substitute A by 17 over 4. Okay? And we will get that the area of triangle ABC equals to 2A. A equals to 17 over 4. 2 times 17 over 4 is 17 over 2. 17 over 2 plus 8 times 7 over 4 times root 15 over 2. So in total we got that the area of triangle ABC equals to 17 over 2 plus 8 times 7 over 4 times root 15. Here we can move 2 to the denominator of this equality, and we will get that, and there we can take a common factor. Instead of 8 we can write down 16 over 2, and we will get that the area of triangle ABC equals to 17 plus 16. 16 over 2 is 8, so we change nothing, times, here we will move 2 to the denominator, so 2 times 4 is 8, so we'll get 8 times root 15. So in total we got that the area of triangle ABC equals to 17 plus 16 times 7 times root 15 over 2 times 8. 2 times 8 is 16, so I'll write it down. So the area of triangle ABC equals to 16. 17 plus 16 is 33 times 7 times root 15. Okay, in total we got that the area of triangle ABC equals to 33 times 7 times root 15 over 16. 33 times 7 is 231. So in total we got that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so the final answer to the question is that the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of this triangle ABC equals to 231 times root 15 over 16 square units. Okay, so that was the first method in finding out the area of triangle ABC. In the next step, I will present to you a second method to find out the area of triangle ABC. Okay? So, first of all, we will find out the value of angle A. The value of this angle, angle A. We know that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C equals to 180 degrees. So I will write that angle A plus angle B equals to 2x, plus angle C equals to x. It is given us in the question. The sum of the three angles in any triangle equals to 180 degrees. Okay? So equality equation number 1 states that the sum of the angles in our triangle ABC equals to 180 degrees. Here 2x plus x is 3x, so I write it down that 3x equals to 180 degrees. 1 minute. A plus 3x, angle A plus 3x equals to 180 degrees. Again, angle A plus 3x equals to 180 degrees. Here we'll subtract 3x from this equality in order to get the value of angle A. So we will get that the value of angle A equals to 180 degrees minus 3x. Okay, so the value of angle A, this angle, equals to 180 degrees minus 3x. Okay, so after we found out the value of angle A, I will present to you a special formula that in this formula we can find the area of triangle ABC. It is the formula for the area of any triangle. So actually it will be rule number 4. Rule number 4 states that in the area of any triangle, the area of any triangle so actually if we have a triangle ABC, we know that side AB of triangle ABC equals to A units and side AC of triangle ABC equals to B units. And we also know that the angle between side AB and side AC equals to theta. Then the area of this triangle ABC equals to A times B times sinus theta over 2. Again, the area of this triangle ABC, according to rule number 4, equals to A times B times sinus theta over 2. Okay, the area of this triangle ABC equals to A times B times sinus theta over 2. Okay, so that is rule number 4. And we can implement rule number 4 in our triangle ABC, because we know the value of AC and the value of AB and also the angle between them. So in this way we will find out the area of triangle ABC. That is the question of this lecture. What is the area of triangle ABC? So the area of triangle ABC, A is abbreviation for area. Area of triangle ABC will be equal to A, that is AC, times B, that is AB, times sinus of 180 degrees minus 3x over 2. Again, we actually implement rule number 4 in our triangle ABC, and we found the area of triangle ABC according to rule number 4, that the area of any triangle equals to the multiplication of two sides, one by the other, times the sinus of the angle that is between those two sides. That is to say, the angle, sinus of the angle that is between side AB and side AC is sinus 180 degrees minus 3x. Okay, so what is the value of AC? AC equals to 14 units. So the area of triangle ABC equals to 14 units times AB. AB equals to 8 units. It is given us in the question. Times sinus of 180 degrees minus 3x. Sine of 180 degrees minus 3x over 2. Okay, so the area of triangle ABC equals to 14 times 8 times sinus 180 degrees minus 3x over 2. 14 over 2 is 7, and 7 times 8 is 56. So I will write it down. The area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. So the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Actually, we have trigonometric identity that states that sine of 180 degrees minus alpha equals to sine alpha. Okay, so we will use this trigonometric identity that states that sine of 180 degrees minus alpha equals to sine alpha. So according to this rule, sine of 180 degrees minus 3x equals to sine 3x. So we write it down. So the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x according to this trigonometric identity equals to sine 3x. So in total we got equation number 1. Equation number 1 states that the area of triangle ABC equals to 56 times sine 3x. In the next step, I will present you a new rule number 5. Rule number 5 is actually the law of sines. Rule number 5 is the law of sines. The law of sines is valid in any triangle. Again, rule number 5 is the law of sines, and you can use the law of sines in any triangle. So if we have triangle ABC that is not necessarily our triangle, but it can be any other triangle. If we have triangle ABC and we have angles alpha, this side BC of triangle ABC equals to A unit in size, side BC of triangle ABC equals to C unit in size, and side AC of triangle ABC equals to B units in size. Okay, so according to the law of sines, A over sinus A is the value of this angle. Capital A is the value of this angle, equals to B over sinus B and again B is the value of the size of this, or the size of this angle, equals to C over sinus C. Okay, so in any triangle, the following equality is true, that A over sinus A equals to B over sinus B and C over sinus C. And I will repeat again that A is the size of this angle, B is the size of this angle, and C is the size of this angle. Okay, so you can use this equality in any triangle, and especially in our triangle ABC, we can use the law of sines. Okay, so in our triangle ABC, we will use the law of sines. According to the law of sines, when we implement the law of sines in our triangle ABC, AC over sinus 2x AC over sinus 2x will be equal to AB over sinus x. Again, this equality is the implementation of the law of sines in our triangle ABC. According to the law of sines, AC over sinus 2x equals to AB over sinus x. Okay, but what is the value of AC? AC equals to 14 units. AC equals to 14 units. So it is 14 over sinus 2x equals to AB. AB equals to 8 units. 8 over sinus x. So equation number 2 states that 14 over sinus 2x equals to 8 over sinus x. So we have another trigonometric identity. From the following trigonometric identity we will find the value of sinus 2x. According to the trigonometric identity, sinus 2x equals to 2 sinus x cosinus x. Okay, the trigonometric identity states that the value of sinus 2x is 2 sinus x cosinus x, so we can substitute sinus x by 2 sinus x cosinus x according to this trigonometric identity. So we will get that (14 over 2 sinus x cosinus x equals to 8 over sinus x. Okay, so we use this trigonometric identity and we substituted sinus 2x by 2 sinus x cosinus x. So here we can cancel sinus x because we have sinus x here in this side of the equation, and we have sinus x on the other side of the equation, so we can cancel sinus x. And 14 over 2 is 7, so I'll write it down that 7 over cosinus x equals to 8. So after we cancelled sinus x, we got that 7 over cosinus x equals to 8. Here we will multiply this equality by cosinus x, and then we will divide it by 8. We will get that the value of cosinus x is 7 over 8. We found out that the value of cosinus x is 7 over 8. In the next step, we will use new trigonometric identity in order to find out the value of sinus x. Okay? We have the following trigonometric identity that states that sinus sine square x plus cosine square x equals to 1. Okay? Sine square x plus cosine square x equals to 1. So from this trigonometric identity, we will subtract cosinus square x, and we will get that sine square x equals to 1 minus cosine square x. So here we will take a root out of this equality in order to find out the value of sinus x. So we will get that sine x equals to the root of 1 minus cosine square x. Okay, so we found out that the sine x equals to the root of 1 minus cosine square x. But we know that cosine x equals to 7 over 8. So if we square this equality, we will get the value of cosine square x. So cosine square x, after we square this equality, will be equal to 49 over 68. Okay, so we know that cosine square x equals to 49 over 64. So here we can substitute cosine square x in this equality by 49 over 64. Okay, so we will get that sine x equals to the root of 1 minus cosine square x equals to 49 over 64. So we got that sine x equals to the root of 1 minus 49 over 64. Here we will write that 1 equals to 64 over 64 in order to have a common factor of 64 on this expression. Okay, actually we took 64 as a common factor of this expression. So instead of 1, I write that 1 equals to 64 over 64. So we will get that 64 minus 49 over 64 equals to sine x. Okay, so sine x equals to the root of 64 minus 49 over 64. 64 minus 49 is 15, so I will write it down. So sine x equals to root of 15 over 64. So sine x equals to root 15 over 64. Root of 64 is 8, so I will write it down. So in total we got that sinus x equals to root 15 over 8. Okay, we found out that sine x equals to root 15 over 8, and we have the first equation states that the area of triangle ABC equals to 56 times sine 3x. That is actually equation number 1. According to equation number 1, sine the area of triangle ABC equals to 56 times sine 3x. And we have already found out that sine x equals to root 15 over 8. So, in order to find out the value of sine 3x, I will present new trigonometric identity for sine 3x. According to the following trigonometric identity, sine 3x equals to 3 sine x minus 4 sine cube x. Okay, we will use this trigonometric identity for sine 3x. sine 3x equals to 3 sine x minus 4 sine cube x. So we will substitute sine 3x by this expression in equation number 1. Okay, and we will get that the area of triangle ABC equals to 56, and sine 3x according to this trigonometric identity equals to 3 sine x minus 4 sine cube x. Okay, so in total we got that the area of triangle ABC equals to 56. In the brackets we have 3 sine x minus 4 sine cube x. In the next step we will take sine x as a common factor of this expression. We will take out sine x as a common factor of this expression. So the area of triangle ABC equals to 56, and we will take out sine x as a common factor of this expression, sine x, and inside the brackets what is left is 3 minus 4 sine square x. So in total we got that the area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine cube x. Okay, we have already found out that sine x equals to root 15 over 8. Okay, sine x equals to root 15 over 8. Here we have sine cube x, so we will square this equality in order to find out the value of sine square x. If we square this equality, we will get that sine square x equals to 15, root 15 times root 15 is 15, over 8 square is 54. So sine square x equals to 15 over 64. So we have all the variables of this equation, and the only thing that is left is to substitute sine x by root 15 over 8 and to substitute sine square x by 15 over 64. Okay, and we will get that the area of triangle ABC equals to 56. Sine x is root 15 over 8. Three minus 4 sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 54 times root 15 over 8. In the brackets we have 3 minus 15 over 64. Here 64 over 8 is 7, and 4, here we can divide 64 over 4 is 16. Okay, so here we will cancel 4 and we'll get that it is 3 minus 15 over 16. Okay, so the area of triangle ABC equals to 56 over 8 is 7 times root 15. In the brackets we have 3 minus 15 over 16, because 64 over 4 is 16. Okay, so here instead of 3 we write down 48 over 16, and we will get that the area of triangle ABC equals to root 15 times 7 times 48 over 16 is 3. Instead of 3 we write down 48 over 16, so we change nothing, minus 15. Okay, so we found out that the area of triangle ABC equals to root 15 times 7. In the brackets we have 48 minus 15 over 16. 48 minus 15 is 33. So I will write it down. So the area of triangle ABC equals to root 15 7 times 33 over 16. So in total we got that the area of triangle ABC equals to root 15 times 7 times 33 over 16. 7 times 33 is 231. So the final answer is that the area of triangle ABC equals to root 231 times root 15 over 16 square units. Again, the final answer to the question is that the area of triangle ABC equals to 231 times root 15 over 16 square units. And in the first method we also got that the area of triangle ABC equals to 231 times root 15 over 16. So in both ways, both methods, we got the same answer, that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this triangle, triangle ABC, and we know that side AC equals to 14 units, side AB of triangle ABC equals to 8 units, and we also know that angle BCA or ACB equals to x, and angle ABC, this angle equals to 2x, and we want to find out the area of this triangle, triangle ABC, and we found the area of this triangle in two different ways. And in the first method, we actually in the first method we made the construction. We draw line segment AD in the red color in such a way to side BC of the triangle, in such a way that this angle equals to 2x. So actually in this way we built an isosceles triangle, because triangle ABD is an isosceles triangle. Anyway, we have here two angles that are equal to each other, and we use rule number 1 that states that in front of equal angles you have equal sides. So in front of this angle we have side AD, and in front of this angle we have side AB. So those angles are equal to each other, therefore also AD equals to AB. But we know that AB equals to 8 units, so AC must be also equal to 8 units. Therefore triangle ABD is an isosceles triangle because it has two sides that are equal to each other. And then we use rule number 2. According to rule number 2, this exterior, in relation to triangle ADC, this angle that equals to 2x is an exterior angle of triangle ACD, and rule number 2 states that the exterior angle, this exterior angle equals to the sum of the two interior angles, equals to angle CAD plus angle ACD. According to rule number 2, the exterior angle ADB that equals to 2x equals to the sum of those two angles, and by solving the equality that states that 2x equals to the sum of those two angles, we found that this angle also equals to x. So here in triangle ACD we have two angles that are equal to each other. Those two angles are both equals to x. Therefore, according to rule number 1, in front of equal angles we have equal sides. So in front of this angle we have DC, and in front of this angle we have AD. So according to rule number 1, AD equals to DC. But we know that AD equals to 8 units, so DC must be also equal to 8 units. Okay, so DC equals to 8 units. So then we used rule number 3. Actually, we have the isosceles triangle. Triangle ABD is an isosceles triangle because side AB equals to side DC. Therefore, triangle ABD is an isosceles triangle. And we have rule number 3 that states that if you draw a height to the base, then that height, if you draw a height to the base of an isosceles triangle, then that height will divide the base to two equal sides. So we can implement rule number 3 in our triangle ABD, and according to rule number 3 we draw the height AE. So that height AE divides the base BD to two equal sides, that is to say, to two equal parts, that is to say BE equals to ED. And then we defined BE as A, and because BE equals to ED, then ED also will be equal to A. Okay, so then we have here a right triangle, because this angle is a right angle, therefore triangle ABE is a right triangle, and also this angle is a right angle, therefore triangle AEC that contains a right angle is also a right triangle. So we implemented the Pythagorean theorem in the right triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BE square plus AE square, and we know that AB equals to 8 units, AE equals to h, and BE equals to h, so 64, AB square is 64, equals to BE square, that is A square, plus AE square, that is H square. Okay, so therefore we can from the Pythagorean theorem we found out that H square equals to 64 minus A square. Then we implemented the Pythagorean theorem on the right triangle AEC. AEC is a right triangle because this angle equals to 90 degrees. And according to the Pythagorean theorem in the right triangle AEC, AC square, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Okay, so we know that AC equals to 14 units, AE equals to H, and EC equals to A plus 8. So in total we got that in the right triangle AEC, AC square equals to AE square plus EC square. AC equals to 14 units, so AC square is 196, AE equals to H, so AE square equals to H square, and EC equals to A plus 8, so EC square is A plus 8 square. Okay, so in total we got that 196 equals to H square plus A plus 8 square. But we have already found out, according to equation number 1, that H square equals to 64 minus A square. So we can substitute H square by 64 minus A square, according to equation number 1. So we substitute H square by 64 minus A square, and we have this equality. Here we have A square minus A square plus A square, so A square is cancelled, and in total we got that we have only one variable here, that is A. So we found out that A equals to 17 over 4 units, and we have equation number 1 that states that h squared equals to 64 minus a squared. Okay, when we found out that a equals to 17 over 4 units. So if a equals to 17 over 4 units, we can square this equality, and we found out the value of a squared. A squared equals to 189 over 16. Okay, so r squared equals to 64 minus a squared, and a squared is 298 over 16. So we found out the only missing variable here is h. So we found out that h equals to 7 over 4 times root 15 units, and we have already found out that a equals to 17 over 4 units. So the area of triangle ABC, the area of this triangle, equals to the base of the triangle times the height over 2. And BC equals to a plus 8, or BC equals to 2a plus 8. And we have already found out that h equals to 7 over 4 times root 15 units. Again, the area of triangle ABC equals to the base BC times the height, that is h over 2. And BC equals to 2a plus 8, and h equals to 7 over 4 times root 15. So and then we found we substituted a by 17 over 4 units, and we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, again, the area of triangle ABC equals to 231 times root 15 over 16 square units. So that was the first method, the first way to find out the area of triangle ABC. Then we found out the area of triangle ABC in a second method, in a second way. So first of all, we found this angle. It is given us that this angle equals to x and this angle equals to 2x, and we know that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle C plus angle A plus angle B plus angle C equals to 180 degrees. Angle A plus angle B, that is 2x, plus angle C equals to 180 degrees. So we found out that angle A equals to 180 degrees minus 3x. This angle A, equals to 180 degrees minus 3x. Then I presented to you rule number 4, that is actually new formula to find out the area of any triangle. According to this new formula, the area of any triangle equals to a times b times sinus theta over 2. Again, the area of any triangle equals to a times b times sinus theta over 2. Okay? The area of any triangle equals to a times b times sinus theta over 2. So we can implement this formula in order to find out the area of this triangle. According to the formula, rule number 4 that I mentioned, the area of this triangle ABC will be equal to AC times AB times sinus 180 degrees minus 3x over 2. The area of our triangle ABC equals to the multiplication of its two sides times sine of the angle between those two sides. So it is AC times AB times sine of the angle between those two sides. AC times AB times sine of the angle that is between those two sides, that is 180 degrees minus 3x. So it is AC times AB times sine the angle between side AC and side AB, that is actually 180 degrees minus 3x over 2. And we know that AC equals to 14 units, AB equals to 8 units, and times sine the angle between those two sides. And so we found out that the area of triangle ABC equals to 56 times sine 180 degrees minus 3x. And we have identity that states that sinus of 180 degrees minus alpha equals to sinus alpha. So according to this identity, sine of 180 degrees minus 3x will be equal to sine 3x. So in total we will get that the area of triangle ABC equals to 56 times sine 3x. And then I presented to you rule number 5, that is actually the law of sines. According to the law of sines, in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. A is the size of this angle, B is the size of this angle, and C is the size of this angle. So in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of sines in our triangle ABC. According to the law of sines, AC over sinus 2x will be equal to AB over sinus x. Again, according to the law of sines, AC over sinus 2x will be equal to AB over sinus x. Okay, but we know that AC equals to 14 units and AB equals to 8 units. Okay, and we have the trigonometric identity that states that sinus 2x equals to 2 sinus x cosinus x. So we can substitute sinus x by 2 sinus x cosinus x according to this trigonometric identity. So we got this equality, and in this equality we have sine x in the denominator of this side of the equation, and we have sine x in the denominator of the other side of the equation. So we can cancel sine x, and after we cancel sine x, we got that 7 over cosine x equals to 8. So from this equality we will get that cosine x equals to 7 over 8. Then we used this trigonometric identity that states that sine square x plus cosine square x equals to 1. From this trigonometric identity, we will get that sine x equals to the root of 1 minus cosine square x. We know that cosine x equals to 7 over 8, so if we square this equality, we will get the value of cosine square x. So cosine square x will be equal to 7 squared, that is 49, over 8 squared, that is 64. So cosine square x will be equal to 49 over 64. So we can substitute cosine square x by 49 over 64 in this equality. So we substitute that cosine square x by 49 over 64, and we got that sine x equals to root 15 over 8. And we have already found out that the area of triangle ABC equals to 56 times sine 3x. And we know also that sine x equals to root 15 over 8. and I presented to you new trigonometric identity that states that sine 3x equals to 3 sine x minus 4 sine cube x. So we can use this trigonometric identity, and we substituted sine 3x in equation number 1 by this expression because it equals to sine 3x. Okay, so triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Okay, or the area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine. So actually we took out sine x as a common factor of this equality, and we got that the area of triangle ABC equals to 56 sine x. Sine x is a common factor of this expression. So inside the brackets, what is left is 3 minus 4 sine square x. And we know that sine x equals to root 15 over 8. If we square this equality, we will get the value of sine square x, and the value of sine square x equals to 15 over 64. So the only thing that is left is to substitute sine x by root 15 over 8 and to substitute sine square x by 15 over 64. Okay, so we substituted those two expressions, and we got that the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of this triangle ABC equals to 231 times root 15 over 16 square units. Okay, thank you very much.